50 years ago, we launched two small spacecraft into the void. This month, NASA almost lost one of them, for good. It started in 1977, when NASA noticed something that happens once every 176 years. The outer planets had lined up. That alignment meant a single spacecraft could slingshot from planet to planet using each one's own gravity. A mission NASA called the Grand Tour. Each Voyager carried a golden record: sounds of Earth, greetings in 55 languages, music chosen by a team led by Carl Sagan. It was a message in a bottle, built to outlive the sun, in case anyone out there ever found it. In 1979, both Voyagers reached Jupiter, discovering active volcanoes on its moon Io that no one expected to find. Nobody had seen another world erupting before. It rewrote what we thought we knew about moons. Next came Saturn, its rings far more complex than anyone predicted, laced with thousands of narrow ringlets. Voyager 1's mission ended there, but Voyager 2 kept going, alone, toward planets no spacecraft had ever reached. In 1986, it reached Uranus, a world tipped almost completely on its side. 3 years later, Neptune. To this day, Voyager 2 remains the only spacecraft in history to visit either planet. It found the fastest winds ever recorded on a planet, over 1,500 miles an hour, on a world that gets almost no sunlight at all. In 1990, at Carl Sagan's request, Voyager 1 turned its camera around and took one last photo, looking back. A single pixel, suspended in a sunbeam. Sagan called it the pale blue dot. That pixel was Earth. Then both spacecraft kept flying, past the planets, past the edge of the sun's influence, into true interstellar space. Voyager 1 crossed that boundary in 2012. Voyager 2 followed in 2018. No spacecraft had ever left the solar system before. Now humanity had two, still transmitting, still working, decades later. But both spacecraft run on the same thing: decaying plutonium, quietly losing about 4 watts of power every single year. Lose enough power, and onboard instruments start shutting down, one by one, forever. Here's the impossible part. Engineers can't touch these spacecraft, can't send a replacement part, and every signal takes nearly a full day just to arrive. Voyager 2 is over 12 billion miles away. A command sent today won't be confirmed, received until tomorrow. So when something goes wrong out there, there is no fixing it by hand. There's only what you planned for, years in advance. This past August, engineers at NASA's Jet Propulsion Lab pulled off something they nicknamed the Big Bang. They switched off 2 heaters and an old tape recorder, replacing them with lower power alternatives, all without touching the spacecraft itself. It bought Voyager 2 at least 1 more year of science. They're planning the same fix for Voyager 1 next. Every year, there's a little less power. Sometime around 2030, the last instrument will likely go quiet. For good, but the spacecraft themselves won't stop. They'll keep drifting, silent, carrying that golden record for billions of years. Longer than our sun will exist. Longer than Earth itself, probably. 2 engineers with a fix nobody asked for just bought a 50-year-old spacecraft more time to keep doing science no one else can do. Right now, they are the most distant objects humans have ever made. Still working, still listening, still sending data home. That's the story most people never hear about the Voyagers. Not the launch, not the photos. The part where a small team just refused to let it end. If you want more stories like this, real space history explained properly, subscribe.